Here is your bonus extra example, and it discusses a shortcut that you can use to solve problems a little bit more efficiently. It's a classic kind of example. 5 cards are dealt from a standard deck of 52 cards. What's the chance of drawing at least one queen? So let's get into it. You can see over here on slide 14, I've written that out as a probability event, drawing at least one queen. And as usual, what we should do is we should break that down into exactly what it means. What does at least one queen mean? It means that I've drawn a queen, or, hence plus, I've drawn 2 queens, or I've drawn 3 queens, or 4, or 5. So if we can work out each of the probabilities, wait a minute, I can't draw 5. If we can work out each of the probabilities of 1, 2, 3, and 4, then we're good to go, right? So let's have a look at these in turn. If I draw 1 queen, well, how many ways can I do that? Well, that would be from the 4 in the deck, I'm choosing 1, and then that leaves me with 48 non-queens from which I'm choosing 4 to make my 5 cards up. Or, hence plus, for 2 queens, that would be from the 4 choosing 2, and then from the 48 choosing 3. Or from the 4 choosing 3, and from the 48 remaining choosing 2. Or from the 4 choosing 4, and from the 48 choosing 1. I stopped doing my multiplication symbols partway through that. And it's all going to be over the same denominator, which is why I didn't bother doing them individually, and that is all possibilities are from the 52, choose 5. Okay, and then we could go about solving that. It's quite long-winded, it's quite tedious to do in your calculator, but you'd get there in the end with a solution. Let me choose to do it a more efficient way. Maybe you need to pause the video and think about what Richard's talking about. How could it be done more efficiently? I'll give you a hint, and then maybe you can think a bit more. Complementary events. Okay, you've either thought about it or you weren't too sure where to go. Remember that a complementary event is the event that something doesn't happen, and that the probability of an event plus the probability of its complement is equal to 1. Another way of looking at that is that the probability of an event happening is 1 minus the probability of its complement. So what's that got to do with our situation here? What's the complement of drawing at least one queen? If you haven't drawn at least one queen, you've drawn 0 queens. Your hand does not have any queens in it at all. So let's have a look at that. So we can say the probability of at least one queen is going to be 1 minus the probability of no queens. Well, what's the probability of no queens? The probability of no queens would be taking all the queens out of the deck. So that would leave us with 48 cards, sorry. So it would be the probability of 48C5, picking 5 from the 48. All over, just to be really clear, the 1 minus is not part of that. All over, from the 52, choosing 5. So again, this top one here is from the 48 that are not queens, I choose 5. So that's the desired outcome. 52C5 is from the 52 cards choosing 5, all possible 5 card combinations. Okay, that's a calculator operation. And if you do it, I've got my notes here on the side, so I can just write it straight down, is 0.341158, or say 0.341. Or it equals 18,472 out of 54,100, and I'll scribble that, but I think it's 145. Could be 165. We'll see it in a minute because I'll switch over to the GDC, and you can see here I've got 1 minus NCR blah blah blah, like what I just wrote, 0.341158. I've then used my approximate function to turn it back into a fraction, so 54,145, which is what I did write down. And here, I would expect you to do it because it's a bit tedious, but you can see right here I've put it in longhand, so doing it the original way, that will give me the top number of that. And then I divided it by NCR 52.5, and the answer is exactly the same, 0.341158, the same as this 1.341158. So it definitely does work, but you can see that it's a much more efficient process to do this than to have to try and calculate this. So be on the lookout for efficiencies.